What's up, .NET developers? Well, the wait is over. Let's talk about union types right here on what's new in .NET and C# with Isaac. Hey folks, isaacrlevin here with another edition of What's New in .NET and C# with Isaac, where we go over all the cool things that are coming out in .NET and C#. And for those not paying attention, the new version of .NET, which is .NET 11, and the new version of C#, which is C# 15, comes out in November of 2026 alongside .NET Conf. All right, well, we're here. And I think one of the things that we're most excited about coming up in the news version of C# is union types. And I'm just going to get right into it. Let's just not do this. Let's just actually take a look at some demos and talk about what actually union types are and why they're cool. All right, so first let's take a look at probably some code that you've written a ton of times before. Basically, the idea is if you have a type and then you have some other types that inherit from that type, how do you actually determine what the actual type is if you're passing in the more generic type on top of that? So this is an example here. I have this iaccessory interface and I have two classes that inherit from it called mouse and keyboard. And then somewhere else in my code, I might have a switch statement or some conditional logic that basically checks what the type of accessory is being passed in. And in this case, this is a simple switch statement where it's mouse, keyboard, and if neither of them happen, it throws a not supported exception, right? So very simple. We've done code like this all the time. So what happens when you do something like this? I'm just going to add a new class. Let's just call this speaker. And then speaker, it's going to derive from iaccessory. And there you go, right? So then what happens in the rest of my code where I need to actually, check that, right? I need to go through and I need to basically find all the other sections of my code that do that, right? And that's not a big deal if I have a smaller code base. But what if I have a huge code base and there's a ton of different projects and the code does things a little bit differently, right? I might miss one. And what will end up happening is in certain scenarios is that we'll run into a situation where we pass an iaccessory in, but it's really a speaker and we don't check for that. So it'll throw an exception where it's not supposed to. And that's not ideal for a lot of reasons. And I think the question that we want to think about is okay, so how can this be a bit simpler? How can this be a bit more straightforward? Well, C# 15 adds a new type of types made specifically to solve this problem, and they are called union types. So in the next few minutes, I'm going to show what they are, why they even exist with even though C# already has classes and interfaces, pattern matching, all those things, and then I have a few demos that show a couple different scenarios. One thing we have to do to our project to set it up is we have to enable the preview version of the C# language. So if you go to your CS project file, make sure your target framework is .NET 11, and you can specify the language version as preview. And what that's going to do is it's going to denote that you're going to be using C# 15 from .NET 11. So let's take a look at a really minimal example of how you would create a union type. So imagine I have 3 record classes here. So I have cat, dog, and bird, and I want to specify a new type that can be only a cat, dog, or bird. So I could do that here like you see on line 13 where it says union, and it's a pet, it can be a cat, dog, or bird. So when we actually go to, let me just run this really quick just so we can see side by side. So let's just do 1. So as you can see here, we are creating a new pet. So this is where you get your implicit conversion. You say specify a pet is a pet and it's a dog and the dog name is Rex. So when you write that out, you get that raw union value of dog equals Rex, right? So that's great. You also have exhaustive switching. So, now that we have this idea of what pet is, and we know pet because we looked at the code earlier as a dog, it'll fire dog here and it'll select that. And then it'll say you can write out the pet's name in that case, which is Rex. So you have this switching, which basically you don't need a default branch, right? Because pet can only be dog, cat, or bird. It can't be snake, it can't be giraffe, it can't be any other because you haven't specified that when you declared the union type. So, and then what happens in the situation where you want a nullable union, right? You can do that here. So we have this nullable, which is maybe a pet, and we're specifying it, actually giving it a value. So we're saying that it's a cat, and the cat's name is Whiskers. And then when we describe that, which is down here, it basically just switches on the type, and then if it's that, it does the same thing as it did earlier, but if it's null, it says no pet. So for maybe pet, we're going to describe that out, and that pet's name is cat, and the pet's type is cat, and the name is Whiskers. You understand. And then finally, we have this no pet, which we actually specify null. And then we describe that out, and then it's going to fire this case statement, and then we're going to have no pet. So this is really, really cool because you only define what you want your union to be. Like there's no need to do conditional logic to check the type and make sure it's not another kind of type if when you have other issues in your code or you have other areas of your code that might be referencing this. So I know what you're probably saying. You're like, well, Isaac, there's other ways to do this. Like we've been doing different versions of this for some time. Like, why do I need this, right? So let me show you an example of like things that I've actually written in the past, code that looks like it, and why it doesn't work 100% of the time. So we're going to take a look at a couple of options, right? So the first option is, I think you saw a version similar to this earlier where you have this abstract class and then you have all these classes that inherit from it, right? This is helpful in a lot of cases, but similar to what we were talking about a bit earlier, right? You're throwing this not supported exception, and these are open classes, which means that some other assembly somewhere could say, I'm going to create a new class called snake, and it's going to derive from pet base. And all of the code that I do that check the types, it doesn't matter anymore, because I'm potentially going to run into an issue where I'm going to throw a not supported exception if somebody happens to pass in a snake. So that's not super helpful. Like you run into situations like this all the time. So that's the first situation. The second situation is like I used to do this a lot with like APIs, where basically like it calls an API. If it returns a value, I say, okay, it was successful. If it returned error, I say it was unsuccessful and return the error, right? So I've written code like this a lot in my career. So, and basically how you would, return from your API is like, okay, well, if it's a success, it would say, okay, and then you provide the value. And if it was an error, you would provide the value there. But what happens in this situation here, right? Where you have a legacy result and you're specifying the success of true, but the value is null. Like logically, that's not correct, right? Because I would expect if success was the true, value would have a value. It wouldn't be null, right? Maybe the error would have a value, right? And that's great. Not really great, but that's just how we've done it. So how does Union fix this? So you have a record class of success and a record class of failure, right? And then you have this union of attempt result, which says it can only be a success or with an excess of t, or it can only be a failure. So when you make an attempt to describe that, it just says, okay, so, look at the succeed, and then if it's true, return all good, and if it's failure, return something broke, right? And then if you have a switch statement, it looks similar, right? There's no default here because you could never have a situation where your attempt result is not success or failure, right? So this is really, really helpful because you're never going to run into situations at runtime where you have a type that doesn't matter. So let's actually just look at a quick demo of this. So I'm going to open this piece up down here. So we talked about it a bit earlier, right? So we have this, this buggy construction, and then we're going to write out basically what that is. And that's this described as a switch statement, if you can remember. So legacy result let us construct an invalid state, so null reference exception. So it throws a null reference exception in that particular case. So as you can see, that's right here. Because we actually said, like, it is a success, but the value is null. That's not okay, right? Then, like, what if you were to do this with unions, right? You could then, so you have this union fix and you describe it and you provide succeed is true, and then you provide a fail, and then you can render out that and that. So again, it's about limiting the potential damage of adding new things to that type. If you want to add a new type to a union, you have to actually go into the union type and actually do it instead of just creating something that inherits from somewhere else. And this is really helpful if you have a ton of teams that are kind of using the same classes because they might want to do something that they might want to create another class that does that. So here's another thing that I've written a bunch in my career, and I imagine you too. So like a method can either succeed or fail, right? Like that seems very, very simple, but in the reality, that's not true. So the traditional approach is you throw an exception for, to continue the control flow of the method, which can be expensive, and then you have to do catching, and then you have to adequately bubble up those exceptions and all those things. Or maybe it returns like an ad hoc pair of fields like we showed earlier, like the result and the value and error message, right? And that can be buggy, and it's not what we want to do. All right, so let's take a look at this example right here. So right now, disregard this commented outline. So I have a record class of parse error, and then from that union, I just have, it's an int. It could be an int, or it could be a parse error, and parse error is a string, right? So let's just start this demo here. So if I go and then I want to parse the age, it just basically goes, it parses the string input, it sees if you do it. If it can't, it does the implicit conversion here. If it can't do it, it throws that parse error message up, and you specify that message in there. So in the situation where I want to report on that, I specify the age that's accepted or the parse error if it was rejected. So when I actually run this in practice, it will say parse agent. So the agent is parse agent is 34. The not a number, which I'm passing in a string, so that's not a valid age range. Negative, same thing. 200, it's not a valid age either because it doesn't pass our criteria. So because our criteria here that I showed is the age has to be between 0 and 150. This is all great. Like right now, this works great. But what happens in the future where if I want to add like a public record called warning, right? So now at this point, it's going to throw error in what I want to do. If I want to say, okay, well now I have a parse result, and that specifies that parse error result. I might need to stop this actually. And then the parse result can now either be a parse error or a parse warning. Whoops. Okay. And I'll build this. I'll get an error mess. I'll get a warning here. The switch expression does not handle all possible values of this input type, right? Because I'm not including parse error in here. So if I comment this out, uncomment that, and then I build again, it's gone, right? So this just gives me like better visibility into what I'm doing. So if I update the union, all of the switches or all the conditions that I check where it checks the type of that particular union type, if I don't specify one of the cases, it will give me a warning inside of the IDE, which is really, really helpful. Okay, well, let's look at another demo. So let me just minimize this. So as you know, like C# already has like nullable reference types. They solve like a lot of the is this null issue, right? But sometimes you want a value that might not exist. So as you can see here, I have another record of class none, and then I have a record class of sum of t, and then I have a union, which can be either none or sum of t. So I have this this method called find user age, and all find user age does is it basically tries to get the value of the name, and it outputs it out as age, right? And then I describe out that. So I found the age, and then if their age doesn't exist or if it's not in the file, it's not in the file, right? Pretty simple. So what does option 4 actually look like, right? So if I pass in, so if I have a collection, in this case a dictionary of string ints, so of Ada, 36, and Grace at 85. So when I loop over that particular collection, so not only am I adding Grace and not only am I checking Ada and Grace, but I'm also checking Linus, right? So what I want to be able to do is I pass in the list of approved items in the collection across this, and I compare it with name. So when I try to do that, it then says, okay, well Ada is found. Grace is found, but Linus is not found. So, and how does it actually do that? So if I go back up here, it passes in the name, it passes in the string of that, or the dictionary of the collection, so the Ada and Grace that I showed earlier, and then the name Linus. It tries to get it. If it can't get it, it returns none, right? And in the situation where I return none, like I show here, it says no age on file. Like this is substantially cleaner than like any other way that we've done it in the past, right? Because it just makes it like so much more readable. And if you've used like in F#, if you've been an F# developer, or in Rust, like have like that option module. This is the same sort of thing, right? So unions provide that same experience, but it's built on top of the object model that C# relies upon. So, in the situation where you could then add additional things to this collection, it's still going to adhere to the same principles that we were talking about earlier. So imagine that you have 3 record classes. You have a create order, cancel order, refund order. You have a union that you've declared that is one of those 3, and then you do some logic here, right? So to basically check. So if it's a create order, you add some strings and you add a quantity. Cancel, it provides order ID, and refund, it provides an amount. So what happens in the situation where you then add shipping to a particular thing? So if you scroll down here, you have these order commands, and it's that, and you write this out. Right, so let's just run this, and that's cool, right? So, but what if I want to add shipping to this as well? So it's as simple as me creating a new public record, right? And then I'm going to then specify the ship order in here, right? And then down in here, I just uncomment out. And then if I run this again, it shows me everything that I want, right? And I can, actually, I got to uncomment this out here too. It handles that shipping that. So basically what did I do here, right? I added a new type of record, right? In this particular case, it was for, the idea that we're going to then dispatch an event for shipping. I added that new record to this union, and then I made modifications to how we handle those particular things, how those messages are then dispatched and handled, and then I just output out on there. So this is code that, I've seen done a lot, and look how much cleaner it is than having to make these changes one by one. And the thing is that the second that I add the ship order, it's going to then, down at the bottom, it's going to say you need to provide a ship order as part of this particular command. So again, another scenario of things just making lives a bit easier. Now I want to show you one more thing, that how you can actually create your own like custom union types, as well as how you can mark particular things in classes as unions. So it's not magic when you add like that union thing. Like basically what happens is when you specify a union of a pet, and it's a cat or dog or bird always, right? This is actually what gets generated roughly by the compiler, right? So you have a public struct of pet, which is an I union, and then you have a public pet, which is a value, dog, bird, etc., right? So basically what this means is that you have the ability yourself to specify and create your own union types and derive how you actually want them to work. And this is available in .NET 11 Preview 5, which you're going to see here. So as you can see, in this example, I have a record class that's a circle, and I have one that's a rectangle. Circle takes in a radius, and rectangle takes in a double and a width. So if I wanted like a fully handwritten, like manual union type, I could do something like this, right? So I could specify a shape, a circle, and then that provides the value. And then I can have like this nullable object that's a value that returns a value as well. So that is basically what you're seeing up there, right? And if I wanted to go even a step further where I could show some non-boxing access pattern stuff, so like using has value, I could use like the int or bool example. So basically you have this concept of, if it's an integer or a bool, if it's a 0, it's none, if it's 1, it's an integer, if it's 2, it's a bool. So when I try to get the value of that here, whether it's an int or a bool, it'll specify out like this. So if it has a value, if it has a value, it's not 0. Where else if it's an int, it's going to return a 1. If it's not an int, if it's a 2, it's going to return a boolean, right? And then you have this switch statement right there for something like that. Also, if you wanted to do like sort of a class-based union, you had this opportunity as well. So similar to what we saw, I think, in an earlier example where you have this result and you have an exception, and you can specify that here. So what does all this look like? So I'm just going to run this demo, right? So go down here. So I'm going to use a manual struct union. So what we've done here, basically what exactly happens or looks very, very similar to the compiler generated one. So I'm specifying a new shape. I'm saying it's a new circle, and its radius is 5. And then from there, I basically do a check where it's like, okay, check the shape. Is it a circle? Yes. Then I'm going to do the, the pi times the radius again. And that's going to give me what the circle is. So in that particular case, it's 78.5-ish, right? And then if you want to use like that non-boxing access pattern that I said earlier, you specify an int or an int or bool. That's your union. We're going to cast this into a nullable int as a 42. Okay, so we have a description here. We're going to specify that. We're going to switch. And then that's going to write out what our description is. In this particular case, it gets cast to as an int, and we specify it as an int, which is 42, right? And then you also, like I mentioned earlier, you can use that class-based union with the reference, and the semantics are still the same. So you specify OK, you can return an operation result of success. If you have an error, you can then throw an operation exception and say failed. So basically, when you do that, you can specify very, very quickly OK or not OK or failed. And finally, the last thing here is if you want any generated or handwritten union, it can be tested generically. You can do that through iUnion at runtime. So you can do shape elements iUnion, shape is iUnion, and then it'll tell you that right here. All right, so with that, I think that's important to just call out a couple of caveats before you start using like unions today. Again, like this is all preview stuff, so C# 15 doesn't officially come out until November 2026. You're also dependent on .NET, so I mentioned for some of the attribute things. And that's not available in .NET officially until .NET 11 comes out in November 2026 as well. And if you actually look at the docs, and I'll put a docs link in the bottom of this video, so it basically says the original proposal hasn't been implemented yet. So later previews are going to have more. So a lot of the demos that I show, like code might change over the course of time, or in the service area is moving a little bit. And just also to call out, so union isn't a record. It doesn't give you like a value. It doesn't give you value quality. It doesn't give you deconstruction. It's purely like which case is this. So it's a better way to handle every single one. If you need a quality, keep using records as your case types. The way every example today I showed you. So given that, honestly, I'd reach for a union anywhere I currently am just faking if I have a base class and I don't need inheritance from it. Or if I have like a DTO full of nullable fields that shouldn't be all at once used. So I would not replace it like every interface that I've ever written with it, to be completely honest. Interfaces are still the right tool when the set of implementers is genuinely meant to be open and extensible by other assemblies. So let's just switch back to me. Yeah, so like I mentioned, union type C#15, it's a closed set of case types, so it's compiler verified exhaustive pattern patching, basically in a nutshell. Its implicit conversions make it work and makes it feel more native and actually, I guess, familiar, even though it is new. It's just not added to the experience to provide a particular use case filling. But they do feel a real gap with open class hierarchies and unsafe nullable field DTOs. And they give C# basically, like the whole reason why this is one of the most requested features, that other languages like F#, Rust, Swift, they already have this and they had it for a long time. So all the code in this video, the result type, the option type, the dispatcher, it's all available in a repo, which I'll share down at the bottom. So my recommendation for folks is to grab .NET 11 preview, preview 5. That's at the time of this recording, that's the newest preview. Set your language version of preview in your project file and start taking a look at some of what these switch statements now look like, and watch the compiler for examples like I showed earlier. Watch the compiler handle things the way that we would expect them to be handled. So that's it for this video. I hope you enjoyed it. It was a bit of a longer one. If you like .NET and C# topics, be sure to subscribe to this channel, like this video, share it with your friends. And I'm interested to know what you honestly think about Union, so comment down below if you like. So that's it for me today. My name is Isaac. This has been .NET and C#, what's new, and I hope you enjoy the rest of your day.